Okay, number 9, we've got this block in motion, pushed across the horizontal floor by this force F at some angle theta. The coefficient of kinetic friction is given, and it's going to the right. We need to calculate the frictional force and the acceleration of the block. So here's our, oops, let me scroll that a tiny bit, get that out of the way. Here's our strangely discolored copied figure. So this is our applied force here, F, on the block. It's coming down at angle theta. We know, let's see, what's a good friction-y color? Let's do this peach thing. So mu k is the friction we got there. Okay, so what are our other forces on the block? Well, we've got a normal force, right? And the normal force is there because it's resisting gravity and also this downward force here. And then, of course, we've got a friction force in the block. Okay, so let's go ahead and do our little free body diagram for the block. FBD block. And let's set up our coordinate system x, y. There is our normal force going up. There, let me do x, y there. Okay, normal force going up, mg going down. This force F coming in at an angle theta, and over here the friction force. Okay, so and then let's go ahead and do N mg, slightly bigger dot there so we can get all these forces out. This is F sine theta. This one is F cosine theta. And this one back here is friction force. Okay, so now let's do our sum of forces. Let's do a sum of forces in the let's start with y. Okay, and that's going to equal, is it accelerating in y, up or down? No. So that's going to equal 0. So here we've got, let me just draw a line there, make sure that doesn't get confusing. There's the normal force going up, gravity going down, and then this F sine theta going down equals 0. Okay, so probably what we get out of here, what we really want to know is the normal force, because we're going to plug that into friction later. And I've told you, once you get experience with these problems, they get easier. So that's sort of an example, is you know that normal force gets plugged into friction, which you're going to need an F eventually. So, or FF, you're going to need and normal force to get friction eventually. So you know when you're doing Y, often it makes sense to solve for normal force. So there you go. And now we know, of course, that, well, we know what the friction force is now. We can, but let's do our sum of forces in the x direction first. And that's going to equal, is the block accelerating? It actually is. We were told it's going to accelerate, or we sort of assume it was going to, since we were asked to find the acceleration, and it was in motion anyway. So sum of force in the x direction, since x is positive and a is pointing that way, just going to be ma. Okay, so let's go with, there's F cosine theta minus the friction force equals ma. Well, friction force is kinetic friction times, or the coefficient of kinetic friction, sorry, times the normal force. Okay, which, let's see, so this is going to equal mu k times mg plus F sine theta. Okay, so I'm going to bring this out here a little more so I have a little more space to write. So F cosine theta minus mu k mg minus mu k F sine theta equals ma. So now we can find a, and a is going to equal, so we divide by m here all the way through. So a is going to equal negative mu kg plus, and then here's where this gets interesting, F over m, So F divided by M, and F over M times cosine theta minus mu K sine theta. And that right there is your answer for A. And they were supposed to find the friction force. So that's part A. And they're supposed to find the friction force. And that's really this. So I'm just going to write this a little neater. Friction force, or the magnitude of the friction force, is mu K times mg plus F sine theta. And I think we were given everything else. So that should be correct for part B. So, yeah, so that is, let's see, I'm just going to do this with the calculator really fast. You can skip this part if you think you understand the problem now. So, let's see, let's get mu K times Fg plus F sine theta. And over here, our mu K 0.25 times our mass was 2.8 kilograms times 9.8. Use mg. Now I can't even remember what it was. Let's see. Paint. All right. Mg plus F sine theta. Right. Okay. Mg plus. And did we know what the force was? I think must have told us that, right? Let's see. And 19 newtons times sine 35 degrees. So, I'm sorry, you couldn't see me typing, but there it is. And that's going to equal 9.58 newtons. Yes, which is correct. And then the magnitude of the acceleration, I'm just going to assume that's right. I'm not going to bother going through that. So there you go. That's problem 9. And I'll do 10 and on in a second.